Welcome to Laws of Indices Level 6. Pause the video now, try the 4 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're told that 4 to the power of 3t minus 2 is equal to 1 over 2 root 2. And we need to find the value of t. Now in problems like these, we'd like to write both sides of the equation as powers of the same number. And we notice here that 4 and 2 can both be written as powers of 2. Starting with 4 to the power of 3t minus 2, this can be written as 2 to the power of 2, because 4 is the same as 2 times 2, still with a power of 3t minus 2 on it. Now looking at the other side of the equation, 2 root 2 can be written as 2 multiplied by the square root of 2 to the power of 1. And the square root of 2 to the power of 1 can be rewritten using this law, which tells us that this will have a fractional power with numerator equal to 1 and denominator equal to 2. So the right hand side of the equation becomes 1 over 2 times 2 to the power of 1 over 2, or a power of a half. Now looking at the left hand side of the equation, we can see that we're raising a power to another power. So we're going to use this law, which tells us that to simplify this expression, we have to multiply the powers together. So 2 to the power of 2 raised to the power of 3t minus 2 becomes 2 to the power of 2 times 3t minus 2. This is equal to 1 over, and in our denominator we're multiplying indices with the same base, so we can use this law to see that we need to add the powers. So 2 to the power of 1 multiplied by 2 to the power of a half becomes 2 to the power of 1 plus a half. Going back to the left hand side of the equation, we can now expand the bracket in the power, and we have 2 to the power of 2 times 3t, which is 6t, and 2 times minus 2 is minus 4. On the right hand side of the equation and looking at the denominator, we can add those powers together, and 1 plus a half becomes 3 over 2. Now staying on the right hand side of the equation, we can use this law to rewrite 1 over 2 to the power of 3 over 2 as 2 to the power of minus 3 over 2. And our left hand side for now remains as 2 to the power of 6t minus 4. Now since on both sides of the equation we've got the same base, which is 2, we can say that the powers on each side must be equal to each other. And this means that 6t minus 4 is equal to minus 3 over 2. And we now have an equation that we can solve to find t. So we can start by adding 4 to both sides of the equation, and this gives us 6t is equal to 5 over 2. Finally, dividing both sides of the equation by 6 leaves us with t on the left hand side, and that's equal to 5 over 2 divided by 6, which is 5 over 12. And that's our final answer for problem 1. In problem 2, we're told that y is equal to 3 to the power of x, and we need to express 81 over 9 to the power of 2 minus 3x in terms of y. Now to start, since y is given as a power of 3, we'd like to rewrite 81 and 9 as powers of 3. And since 81 is 3 times 3 times 3 times 3, we can rewrite our numerator as 3 to the power of 4. Similarly, in our denominator, 9 is 3 times 3, so we can rewrite this as 3 squared, and it still has a power of 2 minus 3x on it. Now in the denominator we can see that we're raising a power to another power, so we can use this law, which tells us that in order to simplify, we can just multiply the powers together. So rewriting our denominator, we have 3 to the power of 2 multiplied by 2 minus 3x. And our numerator is still 3 to the power of 4. Expanding the bracket in our denominator gives us 3 to the power of 2 times 2, which is 4, minus 2 times 3x, which is minus 6x. And our numerator remains as 3 to the power of 4. Now this fraction line means that we're dividing indices, and so we can use this law, which tells us that we have to subtract their powers. So 3 to the power of 4 over 3 to the power of 4 minus 6x becomes 3 to the power of 4 minus, and then in brackets, 4 minus 6x. Simplifying this further, this becomes 3 to the power of 4, and then we can think of this minus in front of the bracket as a minus 1. Then minus 1 times 4 is minus 4, and minus 1 times minus 6x is plus 6x. And simplifying this gives us 3 to the power of 4 minus 4, which is 0, plus 6x, which becomes 6x. Now we'd like to write this in terms of y, and y is equal to 3 to the power of x. Now using our power law in reverse this time, we can rewrite 3 to the power of 6x as 3 to the power of x raised to the power of 6. And since 3 to the power of x is equal to y, this can finally be written as y to the power of 6. And that's our final answer for problem 2. In problem 3, we're told that a root a over the cube root of a squared is equal to a to the power of q, and we need to find the value of q. Now in order to find the value of q, we need to simplify the left hand side so it's written as a power of a. And to start, we'd like to change all of our roots into powers, and to do this we're going to use this law. So starting with the square root of a, this can be rewritten as the square root of a to the power of 1. So using our law, we can write this as a to the power of 1 over 2, or a to the power of a half. Similarly, the cube root of a to the power of 2 can be rewritten as a to the power of 2 over 3, using our law. And this means that a, root a, over the cube root of a squared can be rewritten as a multiplied by a to the power of a half divided by a to the power of 2/3. Now looking at our numerator, we're multiplying indices together, so we can use this law, which tells us that we need to add their powers. So a to the power of 1 multiplied by a to the power of a half becomes a to the power of 1 plus a half. And that's divided by a to the power of 2/3. Now 1 plus a half is 3 over 2. So this becomes a to the power of 3 over 2 divided by or over a to the power of 2/3. And since this fraction line means that we're dividing, we can use this law, which tells us that when we divide indices, we subtract their powers. So a to the power of 3 over 2 over a to the power of 2 over 3 becomes a to the power of 3 over 2 minus 2 over 3. We can rewrite 3 over 2 and 2 over 3 both with a denominator of 6. So we have a to the power of 9 over 6 minus 4 over 6. And this gives us a to the power of 5 over 6. And since in the question we're told that this is equal to a to the power of q, we can write down our final answer, which is that q is equal to 5 over 6, or 5/6. In problem 4, we're simplifying 5a to the power of 7, b to the power of 3, raised to the power of 4, all over the cube root of 8, a to the power of 6, b to the power of 9. Now, to simplify this fraction, we'd first like to simplify the numerator, simplify the denominator, and then hopefully we can simplify the whole fraction more easily. So if we start with the numerator, we have 5a to the power of 7, b to the power of 3, raised to the power of 4. And we can see here that we're raising powers to powers. So we can use this law, which tells us that we need to multiply the powers together to simplify. So starting by putting a power of 1 on 5, we're going to multiply together 1 and 4. So we get 5 to the power of 4. Next, we multiply together 7 and 4. So we have a to the power of 28. And finally, we multiply together 3 and 4. So we have b to the power of 12. Now 5 to the power of 4 is 5 times 5 times 5 times 5, which is 625. So our numerator becomes 625, a to the power of 28, b to the power of 12. Moving on to our denominator, we have the cube root of 8, a to the power of 6, b to the power of 9. Now we can rewrite this as the cube root of 8 multiplied by the cube root of a to the power of 6 multiplied by the cube root of b to the power of 9. Now we know that the cube root of 8 is 2, because 2 times 2 times 2 is 8. So this becomes 2. And on both our a and our b, we have a power and a root. So we can use this law to rewrite these. So the cube root of a to the power of 6 becomes a to the power of 6 over 3. And the cube root of b to the power of 9 becomes b to the power of 9 over 3. Now, since 6 over 3 is 2 and 9 over 3 is 3, our denominator becomes 2a to the power of 2, b to the power of 3. And we've now simplified our numerator and simplified our denominator. So we can rewrite our fraction as 5a to the power of 7, b to the power of 3, raised to the power of 4, over the cube root of 8, a to the power of 6, b to the power of 9, is equal to 625, a to the power of 28, b to the power of 12, over 2, a to the power of 2, b to the power of 3. Now this fraction means that we're dividing the numerator by the denominator. So we can use this law, which tells us that when we divide indices, we subtract the powers. So starting with 625 divided by 2, this can just be written as 625 over 2. A to the power of 28 divided by a to the power of 2 becomes a to the power of 28 minus 2. And b to the power of 12 divided by b to the power of 3 becomes b to the power of 12 minus 3. Since 28 minus 2 is 26, we have a to the power of 26, and 12 minus 3 is 9, so b to the power of 9. And our final answer is 625 over 2, a to the power of 26, b to the power of 9.